I welcome you all in this presentation related with the subject materials processing fundamentals and practical. And in this particular presentation, we will be talking about the die set and the different materials which are used for making the die. And the die set and the die materials are particularly related with the sheet metal processing. About them we will be talking in this presentation. So, here if we see the die sets, initially we will be starting with the die set and its functions, and then what is expected from the die set and how does it work for effectively implementing the sheet metal operations. Then the classification of the dies and the die materials, and then the different types of the dies, like say single station die or multi station die. So, multi station dies include like progressive or the transfer die, and then in single station die we have like the cut off die or the blanking die or combination die or compound dies. Okay. So, so depending upon the number of the operations which are being carried out in one station, we can have the combined or the compound die or cut off die. Then in multi station dies, the work is done in the different stations to complete the job. So, as far as the die set is concerned, die set has the two basically the part. One is the punch shoe, okay, that is the top part, okay, and there is a die shoe, the bottom part. Okay. So, the punch shoe, through the punch shoe force is applied onto the punch and the die shoe supports the die. Okay. So, the punch and die are placed on in between the punch shoe and die shoes. Okay. Then there are these pillars or the rods which will be ensuring the movement of the punch with respect to the die in a particular alignment. So, that is facilitated by the die set. So, the punch and die are mounted in the die set. So, die set is particularly used for mounting the die details like punch and die, this is one, and for ensuring smooth operations of punch and die and to produce the parts as per the requirement, it is important that the relative movement between the punch and die is perfectly aligned. So, the die set helps in ensuring the accurate alignment of the punch movement with respect to the die, and this is the real photograph that we can see the pillars or the rods that will be ensuring the parallel movement of the punch shoe with respect to the die shoe, and these two will remain parallel to each other when the movement is taking place. Okay. So, here you can say the guide pins, these are the rods, this is a punch shoe, this is the die shoe, and when the force is applied, the punch shoe will be moving down, and so that the punch shoe remains parallel to the surface of the die shoe, and accordingly the punch movement will be aligned with the die. Okay. And this will not be causing any trouble as far as the smooth operation is concerned. Okay. Then next thing is like the die and the punch. These two will be ensuring the smooth sheet metal operations either for shearing, okay, like in metal cutting, or for the plastic deformation like in the bending or the drawing operations. So, in all these cases it is important that the die and punch, these are hard, strong and resist to the wear. So, wear resistance, these are the three important characteristics: high hardness, high strength and good wear resistance. So, if these characteristics are there in a die material, then what will happen? Like the die, the punch and die will retain its dimensions. They will not deflect, they will not distort under the application of the force that will be there during the operations. So, if the sharpness of the edges in case of the cutting operation, shearing operation is maintained, then that will help in smooth operations, or in the drawing or the ironing or in other sheet metal operations where only the deformation is involved. In those cases, the dimensional stability is important to maintain the clearance and also to maintain the dimensions, so that shape is maintained. So, if it is sharpness is important only in case of the shearing, but other than the dimensional stability is important to maintain proper clearance, so that the desired the deformation is realized in the sheet metal that is being subjected to the plastic deformation, or the flow of the metal to realize the product of the desired size and shape. Okay. And so therefore, it is very important that material retains its hardness irrespective of the conditions, whether it is low temperature or high temperature, so that it resists the wear, and at the same time it is of the good strength, so that it does not deflect, does not deform during the operations. So, that will be helping in the stability of the dimensions of the die, and these in turn will help in performing the die and the punch related sheet metal operation. These will help in performing the sheet metal operations effectively. Okay. So, the die materials, they are basically the ferrous metals. Okay. So, ferrous metals we have primarily steels. So, depending upon the composition of steel, like high carbon steels, which offer very good high hardness, but very poor resistance against the impact and shock. So, they will be these can be hardened very easily through the water hardening. Similarly, if we add alloying elements like chromium, molybdenum, vanadium, then even air hardening will allow in realizing the desired high hardness without much deformation tendency, due to the high cooling rate that need to be imposed during the heat treatment to realize the high hardness. So, the point here is that depending upon the composition of the steels offer the variety of the response and variety of the material properties for making the dies. So, if say if it is just the plain carbon steels where only the carbon content is controlled, these will be of low cost, and but these will require severe cooling rates, very high cooling rates. So, high cooling rates that will be needed. So, this kind of the material will be good for making the die if we are interested in like the low cost of the material, low cost of the labor, shape is simple and cross section is uniform without sharp edges. So, there are variety of the conditions. Increasing proportion of the percentage of the alloying elements means improved hardenability, reduced critical cooling rate that will be required for imparting the desired hardness, and increased thermal stability. So, they will not be getting softened at elevated temperature. So, we have the variety of the materials. So, like either only the high carbon percentage for water hardening steel is imparted, or we add the alloying elements like vanadium, chromium, molybdenum, etc., or there is a high chromium and high carbon kind of the steel, or we have added the graphite, like high graphite content in the steel, or there is a tungsten carbide. Okay. So, we can have the variety of the steels with the different content of the alloying elements, or we can have the tungsten carbide. So, this is different from the other ferrous metals. Now, we will be talking about the common steels and the tungsten carbide. These are the common die materials. Okay. So, the die material, so water hardening is tool steel is one, where primarily the carbon content is controlled. These are usually low in cost, and the labor cost related with that, because of ease of processing, that is also low. So, if the cost is very important criteria, then we will be going for water hardening tool steels. This is preferred particularly for the simple shapes and of the uniform cross section, because when the dies made of the water hardening tool steels and later on when these are subjected to the heat treatment, there is great chance of the distortion. because of the high cooling rate that is imposed. So, that the distortion tendency will reduce the dimensional accuracy and the shape that will be realized after the heat treatment. Therefore, it is more preferred for uniform cross section without internal sharp corners. Okay. Oil hardening tool steels, these come with the little alloying elements, okay, which will be increasing the hardenability and permitting the steels to get hardened with little lower cooling rates, so that the distortion tendency of the dies made of the oil hardening steels that is reduced. Okay. So, the fine details, when the fine details are needed without any heat treatment related distortions. See, if you want to realize the fine details, but without any distortion that can come from the heat treatment, then oil hardening tool steel will be used. And these oil hardening tool steels offer good machinability, but these are preferred when the material cost is important, but it is not a priority like water hardening tool steels. Water hardening tool steels is preferred when the cost is extremely important. In this case also, cost is important, but not as much as that of the water hardening tool steels. Then air hardening tool steels, these offer the minimum heat treatment related distortions because of the further higher alloying contents and for the lower critical cooling rates. Even air hardening allows the realizing desired higher hardness for wear resistance and resistance to the external stresses. So, these are used when the higher cost is allowed and the surfaces of the die or the punch need to be hardened to the greater depth. So, if the greater depth hardening and fine details without distortion is needed and even higher cost is allowed, then air hardening tool steels with the little greater amount of the alloying elements permitting greater hardenability and the lower critical cooling rates, then air hardening tool steel is used. Then the tool steels with the graphite. So, graphite tool steels means the steel with the graphite content. When it whenever the graphite is there, graphite acts as a solid lubricant. Okay. So, if the operation sheet metal operation is such that there is a significant rubbing of the die with the metal, then the graphite tool steels are preferred, because the presence of graphite acts as a solid lubricant that in turn help in reducing the wear, improving the wear resistance because of the good lubricating qualities. So, the graphite tool steels are preferred when the rubbing between the sheet metal and the die or punch surfaces is significant, that otherwise can lead to the higher wear rate. So, the graphite presence help in reducing the wear through the effective lubrication. Okay. The another material which is very commonly used is the high carbon and high chromium steel. So, in high carbon, high chromium, this can, you see, carbon can vary from 2 to 4% carbon, and the chromium can vary like say from like 4 to 30%. And the good part is, when chromium reacts with the carbon, it forms the chromium carbide, which is hard and stable. So, it does not get softened even at elevated temperature. So, high hardness imparted through the chromium carbide formation results in the improved wear resistance, and that is very useful, especially when the cutting is to be done of the hard metal. So, if the sheet metal processing of the hard metal is to be done, then the high chromium, high carbon steels are found to be very useful. And since the wear resistance is very good, the cost is also high in this case. So, these are preferred when the high volume production is needed and we expect long life without break. Without break means without any failure tendency or the requirement of the repair during the production. So, the high chromium and high carbon steels will be offering the long life. Okay. Long life will allow the continuous operation without a break. Shock resistant steels are preferred when the die and punch, these are expected to have the impact loads during the operation. So, material must show the enough toughness. Okay. And for that, the die and punch which are subjected to the impact loads during the operations, if the die and punch are made of the shock resistant steels, then these can be withstand effectively under shock, impact and high pressure, and therefore the dies must be made of the shock resistant steels, especially the bottom section of the die which experiences the impact. Hot work steels, like although this is not about the hot working of the metals, like hot rolling, hot extrusion, hot forging, but sometimes the sheet metal operations are carried out at a high temperature. So, hot working especially of the sheet metals, okay, like hot trimming. Okay. In that case, it is important that if the hot trimming is carried out, then the material should retain, like die and punch should retain their hardness even at elevated temperature during the hot trimming operations, although high temperature related things are not very common in sheet metal processing. So, if it is about the hot working steels, then we may be having high chromium, high molybdenum and the tungsten kind of the elements. So, these form the carbides which are not just hard, but these are also stable at the high temperature, means they do not get softened, they do not decompose, and they retain their hardness even at a elevated temperature. So, related with that only we have the high speed steel. High speed steel means there is a high percentage of chromium, tungsten and vanadium coupled with the carbon of about say 0.7%. Okay. So, here we have 18% chromium. So, these are the major elements actually. So, when these elements are present, they will be forming their carbides, tungsten carbide and vanadium carbides. Vanadium also helps in refining the grain structure. When these carbides are present, they offer very good high hardness, and not just only high hardness, they offer also very good thermal stability and resistance to the thermal softening. So, high speed steels are preferred for the die making the dies which are involving the heating, like involving the heating means the die and punch are continuously working at a high speed for sheet metal operations at very high speed, say punching of small holes in thick sheets at very high speed, and when this is done continuously, there will be significant heat generation, rise in temperature. So, in order to retain the properties, retain the dimensions, show good wear resistance, it is important that high speed steel kind of the material is used, and this is also you see during the progressive dies this kind of the condition is observed. Another one which is very commonly used especially under very severe conditions of the rubbing of the metal, especially at a high temperature. So, the tungsten carbides is used as for making the inserts which are fitted in the in the suitable seat, which is of relatively low cost, like say the mild steel or alloy steels. So, the tungsten carbide inserts, they will be interacting with the metal in form of like rubbing or the metal at a higher temperature. So, the tungsten carbide, when this is used for making the dies or punches, this allows very high wear resistance even at an elevated temperature. But this should not be preferred, this should not be used under the shock load conditions because of the low toughness. The tungsten carbides offer really very good hardness at elevated temperature, but the resistance to the impact is very poor. Therefore, the shock, these should not be used for shock load conditions. It is used for making the inserts, as I have said, primarily for reducing the cost of the things which are being made, and the dies involving the excessive rubbing, like in extruding holes, burnishing and ironing kind of the operations, the die materials are used. Okay. Now, we will see the different types of the dies and the factors based on which the dies are classified. So, the die classification, depending on the number of stations, we may have single station or multi station. So, the single station like cut off dies or parting of the dies, where just in one go operation is done. So, the either blank is produced or the hole is produced, but in the multi station dies like progressive die or transferred die. So, in single station die can also be, apart from the cut off or the parting of the dies, it can be combination die or compound die. A combination die is one in which both cutting operation and non-cutting operations are performed, like say in this, here the cutting operation is being done and the bending operation is being done. So, deformation is being done to realize the desired shape. So, in one stroke of the ram through the punch, that the force which is applied, there will be cutting and the deformation both. So, the combination dies may involve either the cutting and cutting of the two types like punching and blanking, or it can involve cutting and the deformation. So, depending upon the need, the different kind of the operations can be performed, which can be cutting or non-cutting. In compound dies is one in which a die in which two or more cutting operations are accomplished in every stroke of the press, that is in case of the compound die. So, in case of the compound die, like say the blanking and punching, both are clubbed in one stroke of the ram. Or in progressive dies are made with the two or more stations. Each station performs an operation on the workpiece, and after the first part has been travelled through all stations, each subsequent stroke of the press produces the finished part. So, like say here we can say all these tools are connected with the punch, and in the downward stroke of the punch, the different operations will be carried out at these different stations, and one operation will be performed at each station. So, material is spread from one, and then when it exits we get the finished part. So, like initially it starts with the kind of the whole, and the variety of the operations are performed. Cut off operations. So, advantage of cut off operations, like this is the sheet metal, okay, and the cutting is being done along these lines. So, this will be producing the blank. These can further be processed later on for making the useful products. So, in the cut off die, this is the punch shoe and this is the die shoe, this is the punch and this is the die, and in between the punch and die the sheet metal is placed. When the punch comes down, the cutting takes place. So, this is a simple operation. Mostly in this case scrap is minimum. Okay. So, this involves the cut off operations like punching and blanking. It involves like simple tooling, minimization of the manufactured scrap, means scrap is minimum or nil. Okay. Manufactured scrap is the sheet metal that is produced as a direct result of the manufacturing process. So, it is basically the waste material that is produced as a result of the sheet metal operation of the cut off operation. In case of the parting off, scrap is increased because adjacent part must be separated by at least the twice of the sheet metal thickness to allow the adequate punch strength. So, here say this is the scrap that is being produced, okay, and here this is the punch and this is the die and this is the part which is being produced. So, this is basically the blanking operation, and in between will be having lot of scrap that will be produced. In case of the blanking die, this is the part which is being produced, and the material the material from the sheet which is being fed will be looking like a skeleton, okay, and there is a punch, there is a die. In case of the blanking die, the parts do not have the two separate straight parallel edges. The blank can almost be of any closed contour. It increases the scrap, and edges of the scrap must be separated from the edges of the strip by twice of the sheet metal thickness to minimize the edge distortion. Okay. And the drop through dies, here in this case what we see that there is a punch shoe, there is a die shoe, and in between we have the die and punch, and the sheet metal which is processed when the force is applied through the punch, especially for the trimming operation. This is the punch through trimming. So, once the trimming is done, the processed part falls down. So, drop through die means the processed part will be falling down either into the bin or into the bed of the press, and from there the things are cleared. So, in case of the drop through trimming, basically the trimmed part will be falling down, and therefrom it is collected. So, drop through cut off, like the part after the cutting is falling down, okay, in the cut off, like in form of the blank, or drop through blanking means the metal in blanking means here the blank will be produced. So, the blank is being produced in this way, all right. And the after cutting, through the operation of the blanking, the cut part is will be falling down onto into the bin or into the onto the press bed, okay. So, the blank here is of this shape and blank here. So, these are the non-parallel, having the edges non-parallel, okay. So, and that is why it produces the scrap. If but if we do the stock layouting properly, then the scrap percentage can be minimized. So, these are the compound dies. Say in case the punching and blanking both are clubbed, in this particular case what we can see, initially there will be blanking and then the punch will be working in order to produce the shape. So, the blank like this is produced and then a hole is produced, that will be producing the scrap, okay. So, both the punching and the blanking is being done. So, this will be the result of the blank, and then hole is made by the punching. So, punching. So, when blanking and punching both are clubbed together, we have the compound die, okay. Now, we can have the blanking and drawing. So, here first the blanking is done, then the sheet metal will be deformed to produce the shape. So, initially a sheet metal will be cut by the blanking and then it will be subjected to the deformation for the drying operation to produce the cup shape product. Combination die is one where, like say that in this particular example, the two different types of the operations are being performed. So, station 1, station 2. At station 1, it is the shearing which is taking place to produce the blank, and the deformation is taking place in another case, like the V shape, that the component is produced through the bending or the deformation. So, in this case, the blank and the form die, these are two different dies are being used, and the two can perform the different kind of the operations like shearing and the non-shearing kind. In progressive die, here we can see in progressive die, say material is being moved in this direction. So, initially the hole is drilled, then the semi notching is done at another station, then the notching is done at another station, and then parting off is done at another station. So, this is how sequentially the material is subjected to the different operations. So, in one stroke we will be having all these variety of the operations being performed, and all these tools are connected with the punch shoe. So, once the processing is done in one stroke, we will be having the one product that will be produced. So, now I will summarize this presentation. In this presentation, basically I have talked about the die set, what is the role of the die, and what are the common materials which are used for making the die and punch, and what are the different types of the dies which are used in sheet metal operations. Thank you for your attention.